Okay, good morning again, everybody. So in today's class, we will be looking at minimum and maximum coordinates. Now, I already WhatsApp you all this handout. If you all wish to write it down, you can. I will give you all a few minutes to write it down while we wait on the other students to come in. Or you all could just print the handout from your WhatsApp group if you wish, okay? But this is the handout. I'm leaving it up for the purpose of the online recording as well in case somebody is taking down the notes from the recording. So I will leave it up for about 2 minutes, but you all will have this on the WhatsApp group already. So I will be referring to it throughout this class, right? So in 2 minutes, we'll start class, right? Okay, so let me just quickly explain what is minimum and maximum coordinates, right? Now, sometimes you will be given a quadratic, and as you all know from our class on factorization, as well as when we did the quadratic formula and graphs, etc., I kept on talking about quadratic functions, and I even introduced it to you all when we did factorization, right? A quadratic function is of the form ax squared plus bx plus c, as you all can see here, right? Now, with minimum and maximum coordinates, we are often asked to express it in the form a into x plus h all squared plus k, of course, or sometimes we are asked to express in the form a into x plus b squared plus c. In other words, all they did was replace the h with a b and the k with a c. So sometimes they ask you for the y value or the f of x value. Just remember, when I did functions with you all, I told you all that f of x is the same as y. So if they ask you for f of x, the value of f of x or the value of y, just remember, the y value is always the k value. K value in this case will be this value here. Now sometimes they replace the k with a c. In that case, the y value will be the c value. If you have any questions, say now. Any questions so far? Any questions so far, people? Any questions? You all could say yes, no. I unmuted all of you.
No, sir. No question.
Okay, great. So now we go in with maximum coordinates. Sometimes we are asked to express the same quadratic function in the form k minus a into x plus h squared, or sometimes, remember I told you k is the same as c, right? So sometimes we are asked to express it in the form c minus a into x plus b squared. Now you might ask yourself, how do you know the difference between minimum and maximum coordinates? When we did graphs, we did minimum and maximum value, right? And there was a difference there, a fundamental difference. That difference there is the sign here, okay? Once you see a negative sign in front of the coefficient of x squared, which is a, you know that you have a maximum coordinate there, or a maximum value if you were doing graphs, okay? And that will tell you the shape of the graph, etc. Okay, in this case, it will tell you that it's a maximum coordinate, and you are asked often to express it in this form. Now, I've never seen maximum coordinates come in the past papers. They only bring minimum coordinates, right? So be mindful of that. But you still have to know maximum coordinates because you never know, you all might be the unlucky ones. So again, in this case, y is also equal to k, and y is equal to c if we are using this one. Now, it is important to note that when you're writing your values in this form or this form, we only take the a value and not the sign. Now, this would apply only for maximum coordinates, right? So when you are putting the value of a here, you just put in whatever value it is. You're not putting the sign associated with the a. You always see examples with that just now, so not to worry about it. But you hear me talking about, you're seeing this h here, and you're seeing k and stuff like that. But how do you go about finding that? It's very simple. You follow this formulas here, these formulas here. Now, these formulas are not given in the formula sheet, so you will have to commit it to memory, okay? So to find h is equal to b, whatever b is, all over 2a. So 2 multiplied by the value of e. To find k, for both minimum and maximum, these two formulas apply, right? To find k is equal to 4ac, so 4 multiplied by a multiplied by c, minus b squared. So b to the power of 2, whatever b is, you multiply by itself, right? All over 4a, so that's 4 multiplied by a. You don't have any questions so far? Don't all rush to answer at the same time. I don't know, I can say yes, no on the chat, etc. That's how I know that you all are online, and that's how I take my rule, right? If you're not answering, I don't put you present in my class. Once, okay, so Cheyenne, thank you. Anybody else is present in the class?
Yeah, I'm present.
Hey, Fernandez, you're present, right?
Yeah. So this is like we last class?
No. Because I have a couple other topics to finish. You will be having classes for probably the next 3 weeks with me.
Okay.
And then we have one Sunday class, and that Sunday class is this Sunday coming up. So when we have that class in that Sunday, it's going to be a very, very, very intense class. I'm going to complete an entire topic, a very big topic. So you all try not to miss that Sunday class, please. That's next week Sunday, and I got it from 1 to 4. That's the time I'm doing it, okay? So please make every effort to attend that class, because if you do not attend it, you will be missing out on pertinent information. So please try to be in the class, okay? That goes for everybody, yeah? I know you all have issues waking up Sunday early in the morning, so that's why I prefer the class. I had the class on from 1 to 4 instead. And we might go just a little after 4, depending on how well you all take to the topic. It's a very big topic, and I'm going to try to finish it on a Sunday class, because we need to finish the syllabus by the end of this month, right? I thought the additional Sunday classes would have helped us to finish even earlier, but that it helped to a certain extent. It was helpful. Right, so everybody okay with this so far, this topic so far? Let's do some past papers then. Angelica, you're gonna have to find something to write on. I'm sure there's a pen and a scrap paper somewhere, right? That's not a good excuse, right? Because you know you're gonna have class this morning. You have to be prepared for your class. You cannot attend a class without having anything to write on or any books or anything of the sort. You need to be prepared for your class, right? Because you would have been fully aware that you have class this morning, right? So I'm not accepting that excuse. You know me by now. I don't accept those excuses, right? Right, so let us look at this question in particular, May 2011, number 9b. So we are asked to express the function f of x, and remember that f of x is equal to y, right? We are asked to express the function f of x, which is equal to 4x squared minus 8x minus 2 in the form a into x plus h squared, all squared, plus k, where a, h, and k are constants. That just means that a, h, and k are actual numbers, right? Then we are also asked to state the value of f of x. Remember, f of x is y, and y, I told you all, is equal to k, right? So in this case here, you are asked to find the value of y, and in this case, y is equal to k. I just going through the information with you all, so you all will know what you need to do and stuff. Then we are also asked to find the, okay, Angelica, but still. Next, we are asked to find the value of x for which f of x is a minimum. So in other words, we are asked to find the value of x. I will show you all how to do that as well. So I will demonstrate this example for you all, then I will give you all 1 to 2 for yourself, right? Is that okay with everybody?
Yes, sir.
Okay. So you all know how I used to just record one session for the week because I didn't want to have 3 different sessions. You all aware of that, right? I just recorded one class for the week. Well, I'm going to be recording recording different sessions, right? Because everybody now is at a different pace. My Saturday class is at a different pace. My Monday class, which is you all at a different place, and Wednesday class is also at a different place, right? So I can no longer record do one recording and everybody just watch that because everybody at a different pace now, okay? Because of the makeup class that you all didn't have, that threw back everybody. So by the way, you all should have a makeup class sometime soon, right? I'll let you all know when. Okay, so let's look at this question. I'm gonna do it for you, okay? So we are given 4x squared minus 8x minus 2, and we're asked to express it in the form a into x plus h squared plus k, right? The first thing you have to do is to determine the values of a, b, and c, okay? So remember, this is in the form ax squared plus bx plus c. So that means the value of a is 4, right? The value of b is -8, and the value of c is -2. Okay, people? So now we have to go and find h. Remember, I told you how to find h, right? b all over 2a. So h, what is the value of b? b is -8. So -8 all over 2 into a, which is 4. 2a is 2 multiplied by 4, right? So -8 all over 2 by 4 is 8. So 8 into 8, 1, 8 into 8, 1, the negative do not cancel. So our answer is -1. So the value of h is -1. Next, we have to go and find k. And remember, how to find k, it's 4ac minus b squared all over 4a, right? So k is 4, and the value of a is also 4. The value of c is -2 minus b, which is -8 squared, all over 4, and the value of a is 4. So if you don't know how to do this, you can use a calculator. 4, I'm showing you how to use a calculator, right? 4 into 4, open brackets, -2, close brackets, minus, sorry, don't put a minus here. So we get -32, right? So here we know we put a -32, and we know 8 squared is 64, so minus, and -8 by -8 is positive 64, but this minus here makes this a minus, all right? So all over 4 by 4 is 16. So k is equal to -32 minus 64, which is -96, all over 16. So that means that k is -6, right? So now let's write it in the form that we are asked to write it in. So a into x plus h all squared plus k. So what is the value of a? The value of a is 4 into x plus h. H is -1, right? And a plus by minus is a minus. So this becomes -1. So -1 squared plus k, which is -6. So -6 here, a plus by a minus is a minus. So this becomes -6 or -6. And that is all. Any questions so far? People? You all have any questions? Okay, so you can go ahead and take it down. Remember, we have another part of the question to do, right? Okay, so I'm taking it off now, right? You're gonna take a screenshot or you can watch back the video to get what you missed, right? Okay, let's just quickly go back to the question. So the other parts of the question ask us for the minimum value of f of x. So that was the y value. And remember, y is equal to k, right? And then we also asked for the x value. So let's see how we do that. Let's go back to the whiteboard. So can somebody just tell me what was the final answer? Reagan, you could just point your mic and tell me.
4 into x minus 1, all that squared minus 6.
Okay, thank you. Right. So this is in the form a into x plus h squared plus k. And remember, I told you all, if you want to find f of x, I told you all f of x is the same as y, right? And since we know that y is equal to k, which is this, and we know that k is equal to -6, that means that y is also equal to -6, right? So this is the answer for part 2. And part 3, they ask us to find the x value. So this right here is the x value. That will help us to find the x value, this right here, right? So all you simply do is take x, whatever I have in bracket here, so x minus 1, you put it equal to 0, and then you solve for x. What take away 0 will give us 1? The only answer is positive 1, right? But you have to show you working. So take this, you carry it across, x is equal to 0. This goes across, it becomes plus 1. 0 plus 1 is 1. So x is 1. So y is -6, x is 1. Now, if in the exam they ask you for the coordinates of the minimum value, all you simply do is say, well, you know it's in the form x and y form with the coordinate geometry, right? So in this case, our x value is 1 and our y value is -6. Okay, but that's only if they ask you to write the coordinates of the minimum. Any questions so far?
No, sir.
All right.
No, sir.
Okay, great. So let me give you all a question to do now for me. So I want you all to, I'm taking this off here now, right? I want you all to do Jan 2013 for me. But you all are just doing numbers 1 and 2. If you look at number 3, you are asked to solve the equation 3x squared minus 5x plus 1 equals 0 and expressing your answer to 2 decimal places. Now, this is a quadratic equation here, right? And I told you all to solve a quadratic equation, we can factorize it. We can do the quadratic formula. We can do it graphically. Or we can complete the square. But I didn't teach you all that yet. We're just completing the square. But once you see decimal places there, remember when we did factorization, we got our answers in terms of fractions and stuff. The only one, obviously when we did graphical method, we didn't get anything in terms of decimals and stuff, right? The only one that gave us decimals was the quadratic formula. So automatically here, they are telling you all in a technical way that you have to use the quadratic formula, okay? If you try factorizing it, it might not necessarily work out. But once you see decimal places there, you know you have to use the quadratic formula, right? And even in the exam, if you are trying to factorize a quadratic and it doesn't work out, try using the quadratic formula, it will work out, right? So you're not doing this third one because this third one is a different topic, which is quadratic formula, and we already did that. Right now, we're just focusing on minimum and maximum coordinates, hence the reason I just want you all to do numbers 1 and numbers 2, okay? So try that for me, please, quickly. Okay, so I'm giving you all 2 minutes again, and then I'm correcting, okay? Okay, I'm going to correct now, right? So the question says f of x is equal to 3x squared minus 5x plus 1, and we're asked to express it in the form a into x minus h squared plus k. So let's determine what is our a value. Our a value is 3, our b value is -5, and our c value is +1. So the first thing we have to find is h. H is equal to b all over 2a. So h is equal to b, which is -5, all over 2 by a, which is 3. So h is equal to -5 over 2 by 3 is 6. Right? This cannot be broken down further, so that's the value of h. The next thing we have to do is find the value of k. Now k is equal to 4ac minus b squared all over 4a. So k is equal to 4 into a, which is 3, c, which is 1, minus b, which is -5 squared, all over 4 and the value of a, which is 3. So 4 by 3 is 12, 12 by 1 is 12, minus 5 squared is 25, all over 4 3s are 12. So k is equal to 12 take away 25, which is -13, all over 12. Or if you want, you can say -1 and 1 over 12. Okay? Now we have to write it in the form a into x minus h squared plus k. So a is 3, as you can see here, into x minus h, which in this case is -5/6. So a negative and negative will make this positive 5/6. Oh wait, I think there was an error in this question. Yes, it's supposed to be positive h. So this will make it minus here. Squared. And of course, a plus by a minus is a minus, so minus 13/12, or if you want to put 1 and 1, -1 and 1/12. Right? Questions here so far? And this question also asks us to determine the value of f of x, which is y. So remember, y is equal to k, and k is equal to -13/12. That means that y is equal to -13/12. Similarly, we are also asked for the x value. And remember, I told you all the x value is this value here. So it's x minus 5/6, whatever we have in the brackets, we put it equal to 0. And we take this, carry it across. X is therefore equal to +5/6. All right? So this is the y value and this is the x value, which we were asked to find. Do you all have any questions for me? Say no quickly. Okay. So I'm giving you all a minute to take it down or take a screenshot or something. Okay, I'm taking it off. So now we're going to be looking at maximum code. Could you just excuse me for a minute, please? Okay, sorry about that. Right, let us now look at maximum coordinates. So let me give you a question to do for me. But I will do the first question and then we will start our new topic, right? Because this hardly ever comes, so that's why I don't want to waste too much time on doing it. I'll just do one question for you all, right? Because the next topic that we're going to do is very important. Okay. So in fact, I want you all to try it and then I'll correct it, okay? So that way you'll get practice. So express -2x squared plus 4x plus 7 in the form C minus A x plus B squared. Yeah, do that question for me. Sorry. Can we correct? Yeah, no? Anybody finished? Can I call on somebody to give me the answer for K? Sorry, for C? What did you got for C? Get, sorry. Who that? Where you get? For C?
I didn't get an answer.
You didn't get an answer, how come? Abraham, where you get?
Sarah had an answer.
You what? Musa, where you get?
So I still working on it.
Sure. Cheyenne, where you get?
So I get minus 224.
What? Minus 224 you get? All right. At least it's still my answer, right? At least I know you tried for sure. Can't say the same for the rest of them. Okay, so our values for A is -2. Our values for B is 4, and the value for C is 7. So the first thing we have to do is find H. Sorry, in this case, it's not H, it's B. So B is equal to B all over 2A. Okay? So B is equal to, well, B is 4 in this case, all over 2, and the value of A is -2. So B is equal to 4 over -4. B is equal to -1. Now, all we have to do is find what is C in this case, because obviously we were finding for K, and in this case, the value of K is C. So we put C is equal to 4AC minus B squared all over 4A. So 4 into A, which is -2, into C, which is 7, minus B, which is 4 squared, all over 4 by A, which is -2. So 4 by 2, obviously you can use a calculator, right? But of course, if you're doing a multiple choice exam, you would not be able to do it so. So 4 by -2 is -8, and -8 by 7 is -56, minus, and 4 by 4 is 16, all over 4 by 2 is 8, and of course -8. So -56 minus 16 is -72, all over -8, which will give us +9. You see where I went wrong, Cheyenne?
Yeah.
All right. And now remember, we have to get it in the form C minus A into X plus B squared. So the value of C is 9. The value of A, sorry, minus the value of A. Remember, I told you when you're taking the value of A, you only taking the number, not the sign. That was, I gave you that in a note, and I told you I'll explain it when we do that question. This is what I'm talking about. We're only taking 2. We're not taking -2, because there's already a negative here. All into X plus B, which is -1. A plus by a minus gives us a minus, so we could change this one time to -1 squared. And that's our answer. How many of you got that? Anybody? Somebody? Anybody? Hello. Wow, Simmons, you get it and I didn't say I was getting it? You sure you get it, boy? Oh, okay, okay. Well, I asked who get it? Who finished something? But true, I didn't ask. I really didn't ask you. But I'll ask you next time, right? Don't worry, don't be dumb. Okay, so I'll leave it up for 1 minute. And then we start with our new topic, which is transformation. Actually, no, wait, hold on. I'm starting set theory with you all. Yes, I now remember. Tell me I could stop, right? I mean, take it off, right? not there, right? With or without the light? That's without the light. This is with the light.
With the light.
Okay. Well, that way there's you, right? Because I see the light kind of blocking it off.
I would say without the lights.
Okay, let's have a vote then. How many of you say without the light? Well, all right then. Shall I take off the lights then, right?
Okay, I almost finished anyway.
Okay, no problem.
Is the elements of the, you have a typo.
Yeah.
Coming down to the end.
The order the elements are written does not matter, and elements are never repeated. That's correct. The writing is the English is correct there. Okay, so let me just explain quickly what this means, right? So the topic we are doing today is set theory. There are two ways you can describe the elements of a set or describe a set. First, you can list the elements of the set, and then secondly, you can describe the elements of the set. Now, before you get into set theory, you actually have to understand what is set notation. Now, before we go into set notation, let me just simply try to explain what is a set to you all. So a set is basically a collection of things that have something in common, right? So for example, the set of students in my class, you all have something in common in the fact that, in the sense that you all are all students, or you can say the set of chairs in my classroom, they all have something in common, which is the fact that they are furnitures and you can sit on them, etc. Okay. Let's think of a grocery. When you go to the grocery or supermarket or anything of the sort, when you enter, everything is sorted according to their commonality, right? When you walk in, you don't see, let's say you go into the snacks aisle, you don't see snacks and you see a slab of pork next to the snacks with blood draining all over the place, or you see cheese on the shelf melting out. You don't see those things, right? All these snacks will be together. All the, let's just say the teas that you drink. So all the tea bags will be together. All the glass bottles will be together. All the seasonings will be together. All the meat will be together in the deep freeze. Similarly, you will also have another and butter and sausages, all those kind of yogurt and stuff. And then you will see a next aisle probably with styrofoam plates, styrofoam cups, etc. You're kind of following what I'm saying, right? Yes?
Yes, sir.
Okay, great. So once they have something in common, you can put them together, more or less in a set. Yeah. So set notation. Usually, when you see set, you usually see the set of. Now the phrase the set of is replaced by a pair of curly brackets. So open brackets, the set of, and you put whatever is in the set, and you close the brackets. Now sets are named using capital letters. So each element in the set is separated by a comma, right? So I will explain all of that just now to you all. Now the order the elements are written, it does not matter. So let's just say you have the vowels of the English alphabet. I'm telling you all the set of the vowels of the English alphabet. You can write it A-E-I-O-U, or you can write A-U-E-O-I. The order the elements are written does not matter. That's what this point is saying. And furthermore, the elements are never repeated. That's the most important part there. The elements are never, ever repeated. So can I take this off and do an example for you all?
Yeah, go ahead.
All right. So let's say I tell you the set E is represents the set of alphabet, right? So suppose I tell you the set A represents the set of vowels of the English alphabet, right? The set A is the name of the set, so you put capital A is equal to, remember I told you all the word, the set of is replaced by a pair of curly brackets, so the set of, you open a curly bracket, right? Vowels of the English alphabet, so you write vowels A is equal to vowels of the English alphabet. So which form do you all think this is? Listing form or descriptive form? Anybody? Not all at the same time, don't rush. There are two ways you can describe the elements of a set. Okay, Rennie is saying listing. Anybody else? Reagan is saying descriptive. Correct, Reagan? This is descriptive form, right? We are actually describing the elements. Now, there's another way to write this, which is listing the elements. So A, E, I, O, and U. Now, remember I told you all the order the elements are written does not matter, right? So we could have written E, I, A, O, U. It really doesn't matter. Okay? Now, suppose I tell you all the set of letters in the word mathematics. Now, I want you to pay attention to this, right? So the set of, let's just call it B, for example, right? So the set of is replaced by a pair of curly brackets. So we open the pair of curly brackets. I want somebody to tell me the elements. Can you all tell me the elements of it? I'm turning on everybody's mic. Help me. List the elements. M. Remember the elements are separated by a comma, right? So M, comma.
A, comma.
Uh-huh.
C, comma.
H, comma.
Yeah.
C, comma. And comma.
Uh-huh.
A,
C comma,
comma, B, comma, I, comma, C, comma, S. And yeah.
Anybody disagrees with this?
so what is it?
Let's see if anybody disagrees with this. Is this correct?
Yeah.
No, this is incorrect. The reason being is that the elements, I told you in the first note, the elements are never repeated. Never, never. Here we are seeing an M. Look, we see the next M here. Here we see a T. Look at next T here. Look at A here. Look at next A here. You all seeing the elements being repeated?
Yes, sir.
No problem, Sophia. Okay, so let's redo this question then, this particular one. So it will now be M, A, T, H, E. You can't put back a M, you can't put back a A, you can't put back a T. So
ICS.
CS, correct. So this is our answer. Everybody good?
Yes, sir.
All right. So I'll leave this up for a minute and then I'll take it off. Okay. In case I'm taking it off, you will get a break shortly, right? Next on the agenda is elements of a set. Okay, I'll explain shortly. I want you to just take it on. Okay, so let me just quickly explain what it is. Okay, so that E symbol is not really an E, right? It's an elongated C with a line in the middle. It's a Greek symbol that means epsilon, right? So the symbol, let's call it E. It means is an element of, or it could also mean belongs to. So you see that? So you all know about the equal sign. When you have an equal sign, I have a line drawn through the equal sign. It means not equal to, right? So if the symbol E means belong to or is an element of, then if we have a sign, a line drawn through the symbol E, it just simply means it is not an element of or it does not belong to. So let's look at some examples here. So the first one, U is a member of A. In symbolic form, it will be U is a member of A. Let's look at the other one. 8 is an element of B. That means that 8 belongs to B, or 8 is an element of B. That's where you write it, right? Next one, P is not a member or not an element of X. So this is where you write it. P is not an element of X. And lastly, 3 is not a member of Y. So that means that 3 does not belong to Y. Any questions there? Any questions? Any questions?
No, sir.
Okay.
No, no, sir.
It isn't stink.
What?
Yeah. The rum in it, it's like it's settling you underneath.
Okay, Amira, are we hearing a wrong conversation?
Shit.
So wait, so basically like the signs in number 1 and 2 is the same thing and
Yeah, because this sign, it could mean is a member of or is an element of. It really doesn't matter.
okay, cool.
Yeah. So I could take it off, right, guys?
Yes, sir, I can take it off now.
Okay. Next is the number of elements in a set. I can't even spell number. We're going to Okay, I want you to just pay attention for a minute. So this one is the number of elements in a set, right? So consider the set E. The number of elements in the set A is represented by a common N, and then you open a bracket and you put capital E, because obviously the sets are labeled in capital letters, right? So let's look at A in this case. A is equal to M, N, and P. How many elements are there in this set? Anybody can tell me?
Three.
Correct. So the number of elements in A is equal to 3. So the number of elements in B is how much? How much?
2.
Correct. And the number of elements in C? How many elements are there in C? Odd numbers from 1 to 10. Inclusive means it includes 1 and it includes 10. But since we know 10 is not an odd number, we're not using 10. That's what inclusive means. Inclusive means it includes both 1 and 10, but we know 10 is not an odd number. So let's list the odd numbers. 1, 3, 5, 7, 9. Correct. So let's count how many elements now, because this is in descriptive form. And in order to list the elements, we have to now get it in list form. So 1, 2, 3, 4, 5. The number of elements in C is equal to 5. Okay, I'll leave this up for 2 minutes. Okay, I'm erasing now, right? So on to our next topic. Not topic, sorry, our next subtopic. The empty set. So just stay on this and I will give you all a 15 minutes break, right? So we will start back at 10:45. Is that okay with everybody?
Yes, sir.
Okay. I'm pausing the recording as well, right? So that way we will have 15 minutes of doing nothing. Okay, so let's continue with the note then. So for example, A is humans with 40 toes. Since there are no humans with 40 toes, we write the number of elements in A is equal to, we write the empty set, or
Or
the symbol,
5.
yes,
The
the
answer
symbol for
5.
correct, yes, which is 5.
Okay.
For example, 2 are days of the week that start with L. So the number of elements in R is equal to the empty set or 5. Okay, so basically the empty set is a set of nothing. So if a set has no elements, then it's called an empty set, and it is represented by a pair of open brackets, sorry, empty brackets, or the symbol phi, P-H-I, phi, right? So these are some examples of the empty set. Any questions?
No, sir.
Yes, sir.
Okay,
So,
so yeah.
just a formula related to this. Start from the example.
Not here, you know.
I say if you could just start from the example, I'll bring back a little bit, if you don't mind.
Okay, no problem. So the empty set is basically the set of nothing, right? It is called the empty set or the set of nothing, more or less. It is represented by a pair of empty brackets or the symbol phi. So for example, humans with 40 toes. There are no recorded humans with 40 toes, so that's an empty set. It doesn't exist. So the number of elements in A is equal to nothing, because this is the symbol for nothing, or you can write phi. You don't have to write both, you choose one, right? If you can't draw the curly brackets, just draw a zero looking thing with a slash here. Now, the direction of the slash is very important. It's done this way, okay, not the other way. So of course, if you can remember which direction the slash going, do the smart thing and draw the empty brackets, right? And of course, days of the week that start with L. There are no days of the week that begin the letter L. So the number of elements in R is equal to nothing or phi, sorry, is equal to nothing or phi. Either one you want to write.
Okay, so
Yeah. So I'm taking enough now, right?
Okay, sir.
You all seeing that properly, yeah? I'm trying to erase it because every time I'm writing on the board, it's hitting the whiteboard itself and it's shaking too much.
Yes, sir. Good.
Okay. So let's take out finite and then finite sets. So we'll start off with finite sets. Anyone just pay attention for a minute? So here we have finite sets. A finite set. What do I mean by a finite set? I just simply mean that you can count the number of elements in this set. Hence the reason it's called finite, right? Finite means you can count it. So for example, if I tell you even numbers from 1 to 10 inclusive, that means it includes 1, it includes 10. However, because we know that 1 is not an even number, we do not start with 1. So we start with 2, 4, 6, 8, and we include 10. That's what inclusive means, right? Inclusive means it includes the number. So let's count the number of elements now. 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. So the number of elements in A is 5. We can actually count this. Let's look at example 2. Letters of the English alphabet. So we have A, B, C, D. Of course, you can list all of them until Z. Now, if you do not want to list all of the elements because they are too long to list, after probably the third or the fourth element, you can put a comma followed by 3 dots. And after the 3 dots, you put a next comma, and then you put the last element of the set. In this case, it's Z, and you close it. So that means the number of elements in B, as you all know, there are 26 letters of the English alphabet. So the number of elements in B is 26. You don't count, as you see it here, which is 1, 2, 3, 4, 5, and say, okay, 5. No. The entire set consists of 26 elements. It's just that we put an ellipsis, I think it's called an ellipsis in English. We put an ellipsis to indicate that it goes up until the last digit, Z. Okay? Anybody confused or anything of the sort?
No, sir.
I'm giving you all 1 minute to take it down, and then I'm erasing because we have to move on to infinite sets now. Can I erase it now?
Yes, sir.
Okay. So here we have infinite sets. Infinite, the word infinite comes from infinity, and it means that it goes beyond everything, right? So we cannot count it. So here we cannot count the number of elements. So for example, if I tell you A is equal to the even numbers, the set of even numbers, I didn't tell you from 1 to so and so, right? I didn't give you a limit. I just tell you all even numbers. So that means it includes all of the even numbers in our number system. Now, if we were to list all of the elements of our number system, in our number system, we will never finish. Our grandchildren, great, beyond great grandchildren will still be counting it, and they will never finish. Okay? So here we write our elements 2, 4, 6, 8, 10, and after a couple elements, you put a comma and you put 3 dots. Now this goes until infinity, so here there is no end number. So that's why we have the 3 dots at the end and we close the brackets. Okay? So the number of elements in A is equal to infinity. This is the infinity symbol, right? And A is equal to, let's say, multiples of 5. Now I didn't tell you from 5 to 10 or from 5 to 20. I didn't say that. So I told you multiples of 5. So that means 5, 10, 15, 20, 25, up until infinity. Again, you notice I put a comma and 3 dots. Okay? So the number of elements in A is equal to infinity. And that's how we have to do it. Any questions?
No, sir.
So I'll leave it for you all like about 2 minutes to finish, right? Can I take it off?
Yes, sir.
Okay. So there is a possibility that we will go up until 12:30, right? Because I want to finish this topic. Because we have we have 3 sessions again, 3 Monday sessions again, and I need to finish the syllabus within those sessions, okay? So if we go up until 12:30, then please, you all just bear with me, right? Because I really want to finish that theory today. It's gonna be hard, but I mean, we gotta try to finish the syllabus, right? So let's go on now with the universal set. This word is context here, right? Okay, so pay attention for a minute. Basically, the universal set is the set of everything. It is represented by capital U, or this E looking, this cursive looking E, capital E, of course, right? So here are some examples of a set, and these are the universal set for it. So for example, we have the set of rectangles, squares, kites, etc. They come from the universal set, quadrilaterals, right? Then we have D being 2, 3, 5, 7, 11. This come from the set of prime numbers. So the universal set is the set of prime numbers. Okay. Then we have alpha, beta, and theta, which is the universal set for this is the letters of the Greek alphabet, because these come from the letters of the Greek alphabet, right? So the universal set is the bigger set, right? This is the general set, and from this general set we have subsets, which is a set within a set, and we have rectangles. So for example, let me use a better example. Let's say we had 3 set of Form 5 classes at CTS College, 5A, 5B, and 5C. The universal set there will be the set of Form 5 students at CTS College. That means the set of everything or the set of everybody, right? So the universal set there will be the set of students in Form 5. If we want subsets of the universal set, we will get 5A, 5B, and 5C. They will form subsets of the universal set. So the universal set is the set of everything, which is Form 5 students, and we can get set A, which is 5A, we can get set B, which is 5B, and we can get set C, which is 5C. You all following what I mean by a subset? It is a set within a set.
Yes, sir, we following.
Okay, great. So let's say I also tell you all the universal set will be the set of schools in Trinidad and Tobago. Now we can have subsets of the set of schools in Trinidad and Tobago. If the universal set is schools in Trinidad and Tobago, subsets of these schools will be primary schools, then we have secondary schools, and then we have tertiary schools, which is universities, etc. Now within each of those sets, those subsets, which is primary, secondary, and tertiary, we have other subsets within those subsets. You follow? So within those primary schools, you will have both public school and private primary schools. And then within those private and public subsets, you will have the different set of schools like Catholic, Hindu, Muslim, all of those things. Same thing for secondary and, well, tertiary, I'm not too sure about that one. I don't want to give an example that I'm not sure about. But you're more or less following what I mean by a universal set here, right? Do you all have any questions?
No, sir.
So can I take this off?
Yes, sir.
Okay. So let me give you all an example of what I'm talking about. So let me give you an example of a universal set. So a universal set, let's call it students of CTS college, right? This will be the universal set, right? And within this set, we have subsets. So we have form ones, because they come for lessons. Then we have form twos, we have form threes, we have form fours, we have form fives, etc. You following? So this is a universal set, and these are subsets. We can call this A, we can call this B, C, D, E. Now within these subsets, we can have other subsets as well. So we can have form one students who do English, so English will be a subset of A. We can have students who do maths, which is a subset of B. Students who do science, which is a subset of A as well, sorry for saying B, etc. So within all of these subsets, we have other subsets as well in terms of classes. But the universal set remains the general set, which is the set of students of CTS college. Are you follow? Anybody confused?
No, sir.
Okay. So let's look now at subsets. Instead of me writing it, I'll just put it up for you. You're seeing it? Can you all see it? Hello?
Sir, I kind of seen it.
Kinda. Okay, let me zoom up a little more. Better?
Well, that could work. Yeah.
Okay, great. Emily Sanjay there as well? All right. Okay, so let me just quickly explain a subset. I more or less explained for the example just now. So if all the elements of one set, for example, A, are members of another set, let's say, for example, B, then we can say that A is a subset of B, and this is denoted as A subset B. That's the symbol for subset, right? Of course, the symbol subset with a cross through it is the symbol for is not a member of. So let us look at the examples here. If Q is equal to letters of the English alphabet and P is equal to A, B, C, and D, we can see here that all of the elements of P are inside of Q. Because if Q is A, B, C, D, E, F, G, H, I, J, K, L, M, N, P, Q, R, S, T, U, V, W, X, Y, and Z, and P consists of A, B, C, D, all of the elements of P are inside of Q. So that means that P is a subset of Q. And that's how we write the symbol for it. Similarly, if I tell you all R is equal to the set of integers, then S is equal, and I told you that S is equal to red, yellow, and blue. Therefore, the set of integers will be numbers, and if I give you colors, colors and numbers are not the same. So the set of colors cannot be in the set of numbers. So that means that S is not a subset of R. Are you all following? So P is not a subset of Q. Sorry, my bad. In the first example, P is a subset of Q. Right? That's what the symbols, that looks like a C, but it's not a C, it's an elongated C looking thing. Right? So P is a subset of Q, and S is not a subset of R. Are you all following?
Yes, sir.
Okay. So can I change the image?
Yeah, you can change it.
Okay. Just a minute. Right. Now we're looking at complement of a set. So I am going to finish set theory with you all today, right? So we will go the extra half an hour. I'm giving you all 5 minutes to write this down. I'm just going to get my laptop charger, so please excuse me. Like 2 minutes. Y'all finish writing it out? Y'all finished?
No, sir.
Okay. Y'all should be finished now?
Yes, sir.
Okay, so the complement of a set. One moment. Right, the complement of a set. The complement of a set is the set of all the elements that belong to the universal set except the members of the set itself. What does that mean? I'll show you all just now, right? So if a set is denoted by A, sorry. Just a minute, I lost the image. Complement. Right, great. Right. So if a set is denoted by A, then the complement of A is denoted as A with a small 1 to the top. You all saying that there? A prime? So, for example, if I tell you all that the universal set is 2, 4, 6, 8, and 10, and I tell you all that A is equal to 2 and 6, the complement is everything that is outside of the set of A. Okay? So again, the universal set, we have 2, 4, 6, 8, and 10. And if A is 2 and 6, then everything outside of A forms a complement. So everything outside of A would be what remains, just 4, 8, and 10. You all following?
Yes, sir.
All right. So let's say I tell you all that P is equal to A, B, C, D, E, F, G, H. And I tell you all that Q is equal to A, B, C. Then Q complement will be everything that's outside of Q, which is what remains, which is D, E, F, G, and H, which is what I have here. Any questions so far?
Nope.
All right. So let's move on to our next subtopic. Equivalent sets. Okay, just pay attention for 1 minute. So some students often, in fact, most students often confuse equivalent sets with equal sets. I want you all to note the difference between equivalent and equal sets, so please pay attention, because equal and equivalent sets are sometimes tested in the multiple choice paper as well. They will tell you, they will give you a question, they will ask you, are the sets equal or equivalent and whatnot, right? So equivalent sets have the same number of elements, but the elements are not necessarily the same. For example, if I tell you that A is equal to A, E, I, O, and U, and I tell you that B is equal to 2, 4, 6, 8, and 10. We learn about the number of elements in a set just now. So let's count the number of elements in A. 1, 2, 3, 4, 5. So the number of elements in A is 5. Let's count the number of elements in B. 1, 2, 3, 4, 5. So the number of elements in B is 5. Now the elements in the set, they are not the same. This is letters, this is numbers, right? So what is common between all of them is that the number of elements are the same. So because the number of elements are the same, these sets are said to be equivalent, right? Now let's look at equal sets now. For two sets to be equal, they must have the same number of elements, and the elements are exactly the same. So let's look here. X is equal to 4, 5, 6, and Y is equal to 6, 5, 4. As you can see, the number of elements are the same because it's 3 and 3. And the elements are exactly the same because we have 4, 5, and 6, 6, 5, and 4. They are exactly the same. Remember, I told you at the beginning of the class, the order in which the order in which the elements are written does not matter. So even though I have 4, 5, 6 here, and 6, 5, and 4 here, these two sets are equal because the order in which the sets are written does not matter, right? So in this case, X and Y are equal to each other. I think you follow the difference between equal and equivalent sets. Anybody want me to explain it up one more time? Say no.
Wait one more time.
Sure. Equivalent sets have the same number of elements. So for example, we have in A, we have A, E, I, O, and U, and we have B, which is 2, 4, 6, 8. How many number of elements we have in A? We have 5 if you count them. Similarly, in B, we have 5 elements as well. So the number of elements in A is equal to 5, and the number of elements in B is equal to 5. Now, since the elements are not the same, but the number of elements are the same, these two sets, they are equivalent. Now, the difference between equal and equivalent sets is that equal sets have exactly the same elements, right? That's what equal means. Equal means exactly the same. So X, we have 4, 5, 6, and Y, we have 6, 5, and 4. Now, the number of elements is the same, so we know they're definitely equivalent. And also the elements are exactly the same, so then they are definitely equal because they fulfill these two elements here. Sorry, these two criterions. So the order doesn't matter. So although I have 4, 5, 6, and I have 6, 5, 4, they are same, they're equal, right? So that means that X is equal to Y, and that is basically equal sets. Any questions so far?
No, sir.
Okay. So I'll leave it up for a minute for you, all right? Okay, I'm taking it off now, right? Everybody good, right?
Yes, sir.
Okay, so now we're going to look at Venn diagrams. Okay, just pay attention for a minute. The universal set is represented as a rectangle, right? So inside of the universal set, we have all of the elements. So 2, 4, 6, 8, 10, right? However, we have a subset within the universal set, which is subset A, right? And I told you all here, subset of the universal set are represented as circles inside of the universal set. So here we have A, which is 2 and 6, and everything outside of A will be written outside here, but within the universal set. You can't have anything written outside here, right? So whatever remains that is not in A, it goes within the universal set. So it can come right here. All right? So these here will be A complement, everything that's outside of E. Are you following? Okay.
Yes, sir.
So when you're finished taking it, all right? All right, so I'm taking it off, right? I want to give you our next example. So I'm just taking off this the bottom here. So the universal set, 2, 3, 4, 5, 6, 7, 8, and A would be, let's just say 1, 2, 3, and B would be 5, 6, 7. And if we have to represent this on a Venn diagram, remember the universal set is represented as a rectangle, and you put the capital U to the top, anywhere on the top if you want to put it. You have to put this capital U, people. And of course, we know the elements of the universal set will go in here, right? So 1, 2, 3, 4, 5, 6, 7, 8. It doesn't matter where in this universal set it goes, right? So within this universal set, we have the, well, this is the universal set here, right? Now within this universal set, we have subsets. So we have subset A, right, which consists of 1, 2, 3, as you can see here. So you represent it as a circle, and you write on the circle itself the letter A. Similarly, we have B being 5, 6, and 7. So we draw a circle here, and this becomes B. And whatever remains outside of A and B, it stays outside. Okay, people? And this is how you would represent this set in a Venn diagram. Any questions there?
No, sir, no questions.
Okay, great. I'll leave it up for about 2 minutes. So can I take it off now?
Yes, sir, go ahead.
All right. Now, Venn diagram is very important because it's tested in the multiple choice. So now we're going to look at union of two sets. Okay, so the union of two sets. The union of two sets, let's say P and Q, is the set of all the elements when both sets are joined or combined. Union means you're combining, you're more or less joining, right? So let's say you have S as A, B, C, D, E, F, G, and H, right? And we have G being G, H, I, J, K, L. Then S union G, but this is the symbol for union, and I said here, NB means note briefly, right? It is not a U, right? It's like a kind of bowl, like a soup bowl looking thing. So S union G is equal to A, B, C, D, E, F, G, H. And of course, you cannot repeat the elements, so that's why I didn't have two G and H. So we just continue with I, J, K, and L, right? You all seeing that? Are you all seeing that? Okay, great. So union, you combine the two sets, but you do not repeat the elements because as you can see, there's a G and a H here and a G and a H here. But when I do the union of them, I did not repeat the elements. Why? Because elements are never repeated. And again, elements are separated by commas, as you can see here. So that's union of two sets. Now we're going to look at intersection. So I'm going to give you all a minute to do that, to take it on. We're almost finished, right? So not to worry. I see some people already left the class. I will mark them as absent because they didn't stay for the entire class. I hope you all know that we call roll, right? And when you're not present in class, we do know who you are because there are like 80 something students or 70 something students in this class and only 24, actually 23. In fact, less because some people are using two names and stuff. So yeah. You all cannot depend on watching the YouTube videos. Tell me as soon as I can take it off, right?
Yes, sir, you can take it off.
Okay. Okay, just pay attention, everybody, for a minute. So if A and B are two sets, then the set of elements that are common to both sets is called the intersection of the sets, and it is denoted or represented as A intersect B. This is not an N, just as the symbol for union was not a U, this is not an N, right? But it's the symbol for intersection rather. So does X and Y have anything in common? And if so, what do they have in common? E alone,
Yeah.
E and D. So the intersection is basically what they have in common. So it is set of D and E. Now, if we were to draw this in a Venn diagram, right? Of course, you know the Venn diagram, this represents the universal set. So we write U. There are two sets, X and Y, and since they have something in common, the circles will be drawn as two connecting circles, right? So please pay attention to how you draw a Venn diagram for intersection. So we draw a circle here, and we draw a next circle here that joins with this. So this one is called X, and this one is called Y. What they have in common goes in the middle here. So D and E, and this is X. So whatever remains in X is A, B, and C that comes here. So A, B, and C. Of course, D and E is within X, but it is also within Y, right? So we don't repeat the elements there. Next, we have Y, which is D and E. So we already have D and E within Y. So what remains is F and G. And that's how we have to do it. Any questions there?
No, sir.
Okay. Can I erase it now?
Yes, sir.
Okay. Let's look now at disjoint sets. Okay, so please pay attention. We're looking at disjoint sets, right? If two sets, let's say it's A and B, have no element in common, then they are referred to as disjoint sets. That means that their intersection is empty. So in other words, there is no intersection between them. So A intersect B is equal to the empty set. So for instance, if I tell you all A is equal to 1, 3, 5, 7, 9, and B is equal to 2, 4, 6, 8, 10, and they have nothing in common, as you all can clearly see. So that means that A intersect B is equal to the empty set. Now, if we were to draw this on a Venn diagram, of course, the universal set is represented by the rectangle, and I have a U on the top, and we draw two separate circles. They have nothing in common, so they cannot be drawn as intersecting circles as when we did intersection. So we draw them as two disjoint, or, well, obviously disjointed, two disjointed or two separate circles, and then we put their elements in them. So the elements of A would be 1, 3, 5, 7, 9, which is the odd numbers, and B would be the even numbers, which is 2, 4, 6, 8, and 10. Everybody okay with that?
Yes, sir.
Okay, great. You all hearing me yet? Yeah, I don't know why my phone lost connection to the internet. What is going on here?
Oh, yes, sir, we hear you.
Okay, that means the internet is working, but it's just my phone not connecting to it. Okay, just a minute. Oh gosh, to connect to the router itself now. Just a minute. I apologize for this. Right, are you all seeing it now? Okay, Emily, no problem.
Yes, sir, we've seen it.
Okay, just quickly take it down. Can I take it off now?
Yeah.
Okay, so we are finished with the content aspect of set theory. So we're gonna look at some questions to do, right? Some examples to put everything together now into perspective. So let's say I ask you to draw a Venn diagram. To show sets P and Q given that P is equal to 1, 3, 5, 7, 9, and Q is equal to 4, 6, 7, 8, and 10. Also, list the sets P intersect Q and P union Q. Let us just quickly see how we will do a question like this, right? And then I'll give you all one to try, and then I'll do one with you all again, and then we'll end class there, right? I have 4 more questions to do with you all in total. So here we can see that P is equal to 1, 3, 5, 7, 9, and Q, are you all hearing me?
Yes, sir, we hear you.
Right, and Q is equal to 4, 6, 7, 8, and 10. Okay, let's work out the these things first, right? The P intersect Q. Do they have anything in common? P intersect Q. Anything in common here? Correct. They have the 7 in common. What about P union Q? With P union Q, remember we're joining everything. So it'll be 1, 3, 5, 7, 9, then 4, 6. We do not repeat the 7, 8, 10. And we close the bracket. Okay? So now that we know that there is something in common, we know when we draw our Venn diagram, it will be 2 interlocking circles, or two circles that connect with each other. So we have P here. Yeah.
So because it have 2 7, right? 7 is common. You only put in 1 7 instead of the 2.
Correct. Because I told you at the beginning of the session with set theory that elements are never repeated.
All right, cool.
Yeah. So since we know that it have something in common, which is 7, we put 7 in the middle. And what remains in P is 1, 3, 5, and 9. And what remains in Q will be 4, 6, 8, and 10. And that is all. Do you have any questions over?
No, sir, no questions.
Okay, so while you are taking it down, I'm going to pull up 2 questions for you all to do for me. Right, so I'm putting up 2 questions. I'm giving you all about 5 minutes to do those 2 questions for me. 2 very simple questions. Everybody's seen the questions, right?
Yes, sir.
And please try it on your own because practice makes improvement. Anybody finished?
Okay.
Two minutes again. Okay, your time is up. Let's correct. So let's look at number 1. Let's do the intersection first. So S intersect T. Are there anything in common there? Do we have anything in common?
No.
Right. So this is represented by a pair of curly brackets. Or if you want, you can put the symbol phi. Don't put 2, you just put 1, right? Let's look at the union of them. S union T. Union just means we put them all together. So A, B, C, M, N, P, and Q. And on a Venn diagram, let's see. Of course, you will use your ruler and stuff, right? They will be drawn as 2 disjoint sets. One being S, and the other one being T. So inside of S, we'll have A, B, and C. And the next one we'll have M, N, P, and Q. You all got that?
Yes, sir.
Okay, great. Let's look at number 2. We have to determine A union B. Sorry, A intersect B. Do they have anything in common? A, B, C. Yes, I can see that they have A and they have C in common. Are you all seeing that? Or did you all see that? So A and C. Then we have to find A union B. So A union B. That's how we combine everything. So we'll have A, B, C, D, E, then X, Y, Z, and we do not repeat the A and the C because we already have one. And next, they ask us to write the number of elements in A union B, and this one we don't have to draw any Venn diagram. So let's count the number of elements in A union B. That's this here. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements because A, B, C, D, E, X, Y, Z. If you count it, you will get 8. So how many have you got 8 for this one?
Me.
All right. So let me give you all a minute to take it down, and then I'm going to put up one more question. Yes, Miss Guru, you raise your hand.
Only thing is asking who got this, so that's why I raised my hand.
No problem. Let's just do one more question before we end class. And this one is a past paper type question. That's why I'm doing it. When you all are finished taking it, I'll give you all a minute to take it out. And then I'm putting up the question, and I will do this question, right? And then I'll end the class. Because we just have like 5 minutes again. Okay, so I'm taking this off. Let's look at this particular question here. A survey conducted on 40 tourists was done to find out who visited Anguilla and or Barbuda. 28 visited Anguilla, 30 visited Barbuda, which is B, and of course Anguilla is A. 3X visited both Anguilla and Barbuda. X, that's supposed to be X, did not visit either Anguilla or Barbuda. We have to draw a Venn diagram to represent the information. And also you have to write an equation in X to represent the information and then calculate the value of X, right? So let us quickly see how we will do this. So in our Venn diagram, we draw a Venn diagram. A for Anguilla and B for Barbuda. Of course, they have something in common because how many visited both islands? 3X, right? So 3X goes in the middle here. And how many visited Anguilla alone? 28. And how many visited Barbuda alone? 30, right? Now, if you want to really find out how many visited Anguilla only, the total amount of tourists that visit Anguilla include the 3X who visited both Anguilla and Barbuda. So if you want to find out how many tourists really visited Anguilla, it will be the 28, take away the 3X that visited both islands, because you want to find out for those who visited Anguilla only. Similarly, if you want to find out how many tourists visited Barbuda only, it will be 30, because remember 30 is the total amount that visited Barbuda. So remember, of this 30, 3X visited Anguilla as well. But if you want to find out how many visited Barbuda only, it will be 30 minus the 3X. Let me just write that properly. Everybody good? And the number of students, who did not visit Anguilla or Barbuda, that will be A and B, the complement of all of that, right? Of A intersect B, which is X. So X comes outside here. So this is part A, part 1, which is drawing the Venn diagram. Next, we are required to write an equation. Equation means it includes an equal sign for the total number of persons who visited both Anguilla and Barbuda, right? So all we have to do is say 28, take away 3X, plus the 3X who visited everybody, both islands, plus Barbuda, which is 30, take away 3X, and of course, plus the X that is outside. Everybody good? And of course, this is equal to 40. It's an equation, so you have to put equal to 40. Now, from your knowledge on maths, you can see clearly that this -3 will cancel with this +3. So what we will be left with is 28 plus 30 and -3, x plus x, this will give us minus 2x is equal to 40. And we know that 28 plus 30 is 58 minus 2x is equal to 40. So that's our equation there. That's all you have to do. The third part, let me do it quickly over here. We have to find the value of x. So that will be 58. Take away 2x equal to 40. So we immediately know that we have to take across this 58. So what will we be left with? -2x here is equal to 40. Take away 58. So -2x is equal to -18. Right? We want to get rid of this 2x. So we take this 2x, -2x of course, and we carry it across. X is equal to that's not my, right, -18 all over -2. So that means that the value of x is equal to +9. Everybody good? And that's how you solve a question like this. Anybody have any questions? Say no.
No, sir.
Okay, well, that is the end of class for today. Goodbye, everybody. Please remember
Bye, sir. Have a nice day.
You too, please remember to join the Sunday class, the last Sunday class. It's an important class. Goodbye, everyone.
Okay, sir, no problem. Bye.
Bye.